Okay. All right, so what we're going to do is just day 2 of 4.1. Now, if you had to just give me like a basic phrase, what is an integral?
It's a reverse derivative.
It's a reverse derivative, an antiderivative. It is the area under the curve. And what did we use to approximate the integral before this?
Riemann sum.
Riemann sum. So earlier on 4.1, we actually learned how to take the antiderivative of equations. And do you remember what was at the end of all of those equations?
Plus C.
Plus C. That's what we're going to do today, is actually find C. So we're still doing indefinite integrals, meaning that our answer is an expression or an equation, not an actual number. We'll get to definite integrals tomorrow. So a particular solution of a differential equation is any equation is any solution that is obtained by assigning specific values to the constants in the general equation. Basically, we are going to find plus C. Okay? So before we do that, let's just kind of review on like how to get to the whole plus C part. All right, and if you weren't here or you just totally forgot what we're doing, this will be a good review. So first of all, do you remember what we replaced y prime with? What's another way we can write y prime? I'll give you a hint. It starts with a D. dy over dx. And so that's going to be our first step. Okay, we are going to replace y prime with dy over dx. Okay, and then that's going to equal 3x squared minus 1. Okay, now, the next thing we did, and most of the time, this part was already done for us. That's why you're like, I don't remember practicing this. We only really did this one time in the last lesson. The next thing we did was integrate. But before we integrate, I have y's and x's on the same side. What do we have to do is we have to separate our variables. Meaning we want the y terms on the left-hand side, like dy, we like that on the left-hand side. Dx, though, I don't want. I want that to go to the right side. So what can I do to get that dx to move? Yeah, multiply. So then my next step would be dy equals 3x squared minus 1. I'm going to put that in parentheses so it's all together, dx. And then the next step was actually to integrate. Now, in your homework that you practiced, you just got to pick up at this step right here. You were just integrating. Like it already had the integration symbol and everything. So if you're supposed to integrate dy, remember d stands for derivative. So if you're anti-deriving a derivative, you're left with just a y. Okay? Now on the right-hand side, this is what you've already practiced. So you should be decent at this by now. I'm not even going to say really good. I'm just going to say you should be able to do it. So what is the antiderivative of 3x squared? X cubed. In other words, whose derivative is 3x squared? This is one you can kind of guess and check your way through it. It's x cubed. Okay, because what's the derivative of x cubed? 3x squared. So the antiderivative of 3x squared is x cubed. Okay, what's the antiderivative of minus 1? Minus x, and then we do have to have our plus c. Now technically, we could have put a plus c over here by the y, but it's kind of confusing to have plus c on both sides, and plus c is still just some number, so we're just going to put it on the right-hand side. Like we're going to say we've combined the plus c's. And then from now on, we're not even going to worry about that. Okay, we're just going to have it on the right side. Okay, this is where we stopped before, and this is what we're going to call today a general solution. Okay, general solution, and you can write that down if you want. But we're going to move forward today and actually find what's called a particular solution, meaning we're going to find what plus c is. All right, now I'm going to scroll up, but not all the way. This picture right here is of many curves that are of the equation y equals x cubed minus x plus or minus a number. So the top one is x cubed minus x plus 5. Okay? The bottom one is x cubed minus x minus 9. Okay? In other words, I know those numbers because those are y-intercept. All right? And these are not the only ones. There's actually infinitely many solution curves.
Can you do 1/3 before that's cubed?
No, because there was already a 3 there.
Oh,
So we could have a 3 times 1/3 and it would cancel out. It kind of just worked out nice on this one. But you're right. We could have gone through that stuff. Okay, so I want you to look at the solution curve that contains the point f of 2 equals 4. Okay? Another way to write this would be to write that this is the point 2, comma 4. That was a big erase bubble. Here we go. 2, comma 4. An even more like outright way to write this would be x equals 2, y equals 4. Okay? All of these things are what we're going to call an initial condition. Okay? An initial condition. Initial condition could look like f of 2 equals 4. It could be the point 2, 4. It could even say x equals 2, y equals 4. So I want you to look at the solution curve that has this initial condition. You can even see because they've put a point here. All right, and I want you to either, like with a marker or a highlighter or just with your pencil, darken in the particular curve that goes through that point. Okay, so whereas all of these are representing the general solution, the one I've highlighted in red is the particular solution for this initial condition. Okay? So you have to be given an initial condition to do this next step. Now, it's really nice because they give us the graph. So does anybody know what our plus c should equal? Looking at the graph. How'd you get negative 2? Yeah, the y-intercept was minus 2. So I know that in place of plus c, I should have a minus 2. That will give me the specific curve that I'm looking for, okay? Now, if we're given a graph every time, this is super easy, but we will not be given a graph on any of the other problems we do. So this is how we're algebraically going to figure it out. We're going to take our equation, and we're going to actually plug it, plug in the numbers. So in place of 4, or in place of y, I gave it away, 4. In place of x, we're going to write 2. And we're just going to crunch the numbers. So again, I'm pretending that I don't know that plus c is negative 2 for a minute. We're going to solve it out algebraically. And so 2 cubed, that would be 8. And 8 minus 2, that would be 6. This is all something you should be able to do without a calculator. And if I subtract 6, 4 minus 6 is negative 2. So this is how you figure out what the c value is algebraically. You plug in your initial condition and you solve for c. So up here on our steps, we're going to add that in for step 4. We're going to plug in, I'm going to use IC for initial condition. If you're like thinking, I'm not going to remember that 2 days from now, write out the words initial condition. Okay, plug in initial condition to find C. And we're still not quite done. I'm going to even change to a different color here. My 5th step, I just want you to write final answer. I have not actually put everything together to write my final answer. Okay? I have my general solution. I have the C, but my final answer is going to be what we call a particular solution, which basically puts these two things together. Okay, puts that together with this. So my final answer is y equals x cubed minus x, and then in place of plus c, I'm going to put minus 2. You could put plus negative, that would be totally fine. And you could even, instead of y, write f of x. That would be fine too. But leaving it as y equals is totally fine. Okay? So this right here is my final answer. What does PS stand for?
Particular solution.
particular solution. That's important because the directions on the next page are going to tell you to do this. So we're going to practice this. Okay, it says find the general solution, find the particular solution. All right, the general solution is the plus C one. Okay, but the particular solution is the one you do after you find C. Okay, so this already has dy over dx, so I'm just going to rewrite it. Now, one thing we do need to do is, at some point, I'm going to have to integrate. And I don't know how to integrate 1 over x squared. So how can I rewrite that?
X squared to the x and the negative 2.
Yeah, negative, and then x to the negative 2. You do it now, do it later, doesn't matter, but you're going to have to do it at some point before you integrate. Okay, now we need to separate the variables. I've been really picky about this. On the AP test, they always have problems like these, and they're generally harder than the ones that we're practicing. This is the first time we're doing this. But you always, out of those 9 points, you get a point just for showing a separation of variables. That's like the easiest point to get, but you won't get it if you're skipping steps. So that's why I'm not going to allow you to skip steps. So I'm just going to take the dx and move it over to the other side. This whole separation of variables thing could possibly be more difficult, but it won't be during this chapter. So we'll worry about that when that time comes. We'll worry about that right now. So we've separated our variables. Do you remember the next step? Yeah, we integrate. So I put the integration symbol on both sides. And the left side is really easy to integrate. Again, that's going to change in the future. But for right now, that's just equal to y. And so what is the antiderivative of negative x to the negative 2? Well, first of all, what's going to be the new power? Is it negative 1 or negative 3? What do we do to the power? We add 1. So negative 2 plus 1 is going to be negative 1. We already had a negative in front. And then now I have a separate negative. That makes that a plus. If you're like, that's hard, that's easy, I'm going to get that mixed up. Well, you're right, you might get that mixed up. So this is why you kind of check your work here. Okay, let's say you thought that this should have been a negative. Okay, let's say this is what you wrote. You would pick up on this because you'd say, okay, what is the derivative of negative x to the negative 1? Well, negative 1 times negative, that would be positive. And then, but I'm supposed to have a negative here. So you see what I'm saying? You catch your mistake. All right, there should not be a negative right here. However you figure that out, it should just be x to the negative 1. The negatives end up canceling, basically. All right, and then we know we need plus c. Okay, so this is our general solution. That's great. Now we need to do our particular solution. This is where you use your initial condition. The mistake most students make here is they mix up like which one goes in where, okay? So which one of these two numbers goes in for y? 3, okay? Remember that f of x equals y. Write that on your notes if you need to. That's how you can remember this. So I plug the 3 in for the y, and then I plug the 1/2 in for x. So then the next thing is, okay, well, what is 1/2 to the negative 1? Well, remember, a negative power means reciprocal. So that becomes 2. So 3 equals 2 plus c, and then c equals 1. And this is great. It's not my final answer. My final answer, which is the particular solution, is y equals x to the negative 1 plus 1. If you wanted to, you could rewrite this x to the negative 1 as 1 over x. And in a multiple choice question, they might do that, okay? Have that as an answer. How could you check this? Like, if you take derivative of this, what should it equal? Yeah, what they tell you dy over dx should equal. So do you know how to take the derivative of this? Yeah, you do. We did that all last semester. So if you took this derivative, you do, and you should get negative 1 over x squared. If you plugged in 1/2 in for x, You do, and you should get 3. So if you just check these two things, you know for sure you got the right answer. There shouldn't be like, I think I got it right. You should be able to check it, know for sure, okay? All right, I want you to do the third one, number 3. I want you to do this one on your own. And when you get your final answer, I want you to check it the way that I've just talked about. Okay, let's go ahead and pick up on this together. If you're struggling with the whole what is the antiderivative of 6x squared, let me remind you of the way that we did this when we started out. We wrote 6, we left a space, we wrote x, we said, hey, add 1 to the power and write the reciprocal in front. So this 6 times a third, what did that turn out to be? 2. You can leave it as 6 times a third, or in this case, because I'm going to do something with it, it may be helpful to go ahead and write that as a 2. All right, and if you can figure that out in your head, that's even all the better. But, so you have options here. All right, what was next? Minus, what was the antiderivative of -1? X, and then plus c. So this was my general solution. All right, you plug in place of y, you should have plugged in a 0. Again, the most common mistake is students plugging a 3, like they're switching the 3 and the 0. That's the most common mistake. All right, 3 cubed, remember, is 27 times 2 is 54. And 54 minus 3 was 51. So C ended up being -51, which seems kind of weird, but that's okay. So your final answer, your particular solution should have been y equals 2x cubed minus x minus 51. Now, did anybody check this to see that the derivative was 6x squared minus 1? Well, let's check it. Is it? Okay. If we plugged in 3, do we get 0? I mean, could you do that? Maybe you didn't have time to do it, but you could do it. And on a quiz especially, that's something you might want to do because it's really easy to make little tiny mistakes here. Okay? All right, let's do this last one together. This is a second derivative. We're going to do it the same way, though. We're just going to have to do the process twice. So do you remember how to write f double prime in terms of d? Do you remember where? D squared y over dx squared. Now really this is like dx, the whole thing is being squared. But it's not that big of a deal if you thoroughly understand that. It's totally fine. Okay, that equals 6x. Now remember we got to separate our variables. Same thing. So this would be d squared y equals 6x. And if you want to put that in parentheses you could, or you wouldn't really have to, especially since it's a single term. But you got to move the dx squared over that side. Now that I've separated my variables, I am ready to integrate. Okay, now, we know that when we integrate dy, we're left with just y. What do you think you get when you integrate d squared y? Y prime, well, I'm going to write it as dy. In other words, when you integrated, one of the d's kind of goes away. That's an easy way to think of it, but you're left with dy. All right, what's the antiderivative of 6x? Because remember, when you do antiderivative, the dx squared and the dx over here is just part of the notation. You're really looking at just this.
3x squared.
3x squared. You might have written this as 6 times 1/2 x squared. Either way, it's 3x squared. And I have a plus c, and I'm going to put this in parentheses, and I'm going to write dx, because I did take a derivative with respect to x, but I still have one left. All right, now, you may be thinking, let's integrate again, because I still have d's there. But what would I then do with this plus c? That could get confusing. So what we're going to do is we're going to stop, we're going to use the first initial condition, okay? And we are going to find this plus c. So before I do that, I got to think, okay, well, what's f prime? F prime is dy over dx. So I kind of have to take a step back here. And I'm going to divide over that dx to make it look like what I'm used to seeing, okay? And f prime of 2 equals 13. That means that the derivative is 13. So in place of dy over dx, I'm going to write 13. In place of x, I'm going to write 2, because that number in parentheses always means x. That's not changing. All right, so let's finish this out. Let's solve for c. So that would be 2 squared would be 4, times 3 would be 12. And so c is just 1. Okay? And so what I can do from here is, and I'm going to switch colors here, I can go ahead and rewrite this, but instead of writing plus c, I'm going to write plus 1. And now I'm ready to integrate again. So it's kind of like, now we got to do the process over again. So you do the process once. You separate your variables, you integrate. You kind of have to do this one little step backwards to solve for c, using your first initial condition. Now I'm going to integrate again, and from here on out, it's just like the other problems. So the integration of dy is just y. What's the antiderivative of 3x squared? X cubed. So for me, this is just all that stuff that we practiced before. So if you're like, I forgot everything we learned last week, you may want to go back and watch that first video from last Thursday. And then plus c. Don't forget your plus c. Now, can I say that this plus c is 1 because I found it as to be 1 over here? Do you think I can do that? No. We know that plus c changes from problem to problem. Well, in here it changed within the problem. Okay? So there are some teachers and some books that may say, hey, you need to like start using subscripts here. And then call this c sub 2. All right? I am not one of those teachers, and the AP test does not require that, so I'm not going to do that. But you may be, if you're getting confused about this plus c, like, wait, is this the same as that? You may want to use subscripts. Okay? My whole thing is plus c is just some number until you plug in your initial condition. Okay? As soon as you plug in your initial condition, that c is locked down and we got to find it right then. Okay? So that would be 1 cubed plus 1 plus c. So what does this c equal? 2. So my final answer would be y equals x cubed plus x plus 2. Which you can check just like how you, excuse me, you can check this same way as any of the other problems. Plug in 1, make sure you get 4. You can find the derivative, plug in 2, make sure you get 13, and you can find the second derivative, make sure that's 6x. So it's really easy to check. It's a little annoying, a little tedious, but you can check it.